Hello everyone. Hi. Welcome to Ask IITians. So this is today we are going to talk about a very interesting chapter, that is area of parallelograms and triangles. This chapter is from grade 9, and every year, like in your final exams, you can see at least one question from this chapter has a weightage of 3 to 4 marks in your final exams, and this is lecture number 1 of area of parallelogram and triangles between same bases. So let's quickly see what about and what is this chapter about, right? So in a brief, when you can see that there are two parallel lines, L1 and L2, such that L1 is parallel to L2, right? There are two lines and they both are parallel to each other, right? Now when we say they are parallel to each other, the distance between them is fixed, right? The perpendicular distance between them will always be fixed, and let's say that distance is h, right? So as you all can see, I have marked that distance as h. Now when you are trying to draw two triangles between these two parallel lines, right? Triangles between same parallels, which means when you are trying to draw these two triangles ACE and triangle BDF, right? Triangle ACE and triangle BDF. When you are trying to draw those two triangles, we can clearly see that they will have the same height, right? They will have the same height because they are between same parallels, so they are supposed to have the same height. Now if we are drawing those two triangles, that is triangle ACE and BDF, in such a way that if CE is equal to DF, if CE is equal to DF, that means if the bases of both the triangles are equal, then we can say that the area of both the triangles is also equal, right? Because we have already said that they are between same parallels, which means they have same height. If they have same height and you have drawn the bases as equal, then their areas are supposed to be equal, because area of triangle kya hota hai? It's half into base into height. So if the heights are equal, bases are equal, the areas are supposed to be equal. Similarly, if you are drawing parallelograms between these two parallels, that is quadrilateral ABCD, you all can spot in the diagram quadrilateral ABCD, right? Quadrilateral ABCD and quadrilateral ABEF, right? Quadrilateral ABEF. These both will also have equal area because they are between same parallels L1 and L2, so their heights are same, and they are drawn with same base, that is they have a common base AB. If they have a common base, same base and same height, the area of parallelogram is equal, right? What is the common base? It's AB, as you all can see in the shaded region, right? The common base is AB, correct? Now let's start with a couple of theorems in this chapter. So now we will be proving that parallelograms on same base and between same parallels are equal in area. Same parallels implies that same parallel lines, and same base means they have a common base AB, right? So let's now try to interpret. So it says given AB is parallel to CF. AB line L1 is parallel to line L2, we know, and we'll say AB is parallel to CF. And we are given that quadrilateral ABCD and quadrilateral ABEF are parallelograms. So both these quadrilaterals are parallelograms, ABCD and ABEF. Okay. So if they are restricted that these parallelograms are between same parallels, it implies that they have the same height. If they have the same height, and we are also saying that they have the same base AB, right? ABCD and ABEF. AB is used to draw both of these parallelograms, right? So now what we have to prove is that area of both these parallelograms are equal. ABCD, ABEF. We have to prove that both these parallelograms have same area, right? So we said that since AD and BC are parallel and AF and BE are also parallel, right? As you all can spot in the diagram, AF and BE. These both are also parallel because it is given that they are a parallelogram. It is given that ABEF is a parallelogram, right? So we would say measure angle AFD. Now, if you all can spot AFD here in the diagram, this is measure angle AFD. This should be equal to measure angle BEC, right? The reason for that is corresponding angles because they are between same parallels and they are forming corresponding angles. So corresponding angles are always equal, right? It's like we have studied this in lines and angles chapter. That is, if you have two parallel lines and you have a transversal, so you say that these two angles are equal because corresponding angles, right? Similarly, when you now come to other angles, that is ADF and BCE, right? Angle ADF and angle BCE, right? These two have same angles. Why? They are again corresponding angles, right? So both of these are corresponding angles. So similarly, we can say triangle ADF and triangle BCE are actually congruent to each other because both of them have two angles in common. So they are congruent by AA test because the sides angles are equal, and if two triangles have both the angles as equal, we say they are similar or they are congruent to each other. So if they are congruent, their areas are also equal. So we have not yet proved that the parallelograms will have same area, but we have proved that area of triangle ADF will be equal to area of triangle BCE, right? ADF is equal to area of triangle BCE. Let's name this as equation 1, right? Now consider quadrilateral ABCF, the entire trapezium ABCF, right? When you are considering ABCF, if you subtract ADF, if you subtract triangle ADF from this, like just concentrate, if you subtract triangle ADF from this, what do we get? Don't you think we will get ABCD quadrilateral? Yes, we would get ABCD, right? So we would say quadrilateral ABCF minus ADF gives us ABCD. Similarly, ABCF में से अगर हमने BCE निकाल दिया, that is this other triangle, if we subtract, we get the ABEF, right? Now we can clearly say that since triangle ADF is equal to or is congruent to triangle BCE, this is from equation 1, right? Then therefore we can say this gets cancelled out. We will say that a quadrilateral area ABCD is equal to area of quadrilateral ABEF just by adding these two equations, right? So in this case, we can clearly see that both of these are equal area. Now in this theorem, we have somehow proved that both the parallelograms will have same area if they are between same basis and same parallels, right? Now in this theorem, we have also proved actually that the triangles having same base and between same parallels are equal in area, right? We have also proved this thing that they are equal in area, right? Because triangles between same base and same parallels are also equal, right? So this is a very important theorem. Now let's see another theorem. It says a parallelogram and a rectangle on the same base and same parallels are equal in it. So far we had proved about two parallelograms, that is two parallelograms having same base same area are equal, uh, in having same base and between same parallels are equal in area. Now we would be proving that a parallelogram and a rectangle between same parallels and on same base are equal in area, right? So we are given now that L1 is parallel to L2. There are two lines where L1 and L2 are parallel, right? Quadrilateral ABCD is a parallelogram, it is given, and quadrilateral ABEF is a rectangle, this is given, right? So we'd say area of parallelogram is base into height. So if you are considering ABCD, let's consider the base as AB and its height is BE. So you would say it's AB into BE, area of parallelogram ABCD. Similarly, area of rectangle is length into breadth, right? So area of rectangle ABEF, its length is AB, its height could be, its width could be BE, right? So AB into BE. So from here, directly we can say that area of rectangle ABEF is equal to area of quadrilateral ABCD or parallelogram ABCD, right? So hence this is how we proved, just by using geometrical diagrams, right? So I hope both these theorems are clear and uh, very simple. I know that these are very simple because they are straightforward theorems, because you are just drawing parallel lines and doing some basic geometry, right? So here we say, let's consider a question now. We would be talking about that. Let's say this is quadrilateral ABCD. This is a quadrilateral ABCD. In this, we are given that triangle ACB have same area as triangle ADB. Okay. AB is the diagonal of this parallelogram. The above half and the below half are equal in area. And we are also given that CL is perpendicular to AB and DM is also perpendicular to AB. So CL and DM both are perpendicular to AB. Okay. We have to prove that CO is equal to DO. CO equal to DO. This is what we have to prove, right? So triangle ABC and ADB, ABC and ADB have same area and same base. ABC have same area and ABD have, they have same area and they have same base. Base is AB. And why do they have same area? Because it is given in the question, right? And we will say when two triangles are joined by their common base, a parallelogram is formed, which means quadrilateral ABCD now is a parallelogram because the remaining two triangles have equal area and a common base, right? So diagonals of a parallelogram bisect each other. Therefore, AO will be equal to BO. Similarly, CO will be equal to DO. Diagonals of a parallelogram bisect each other. This is the property which we have used in proving this theorem, right? How did we say that this is a parallelogram? Because it is, the diagonal is dividing the quadrilateral into two equal halves and which of equal area. So in that case, it has to be a parallelogram, right? And hence we can say that CO is equal to DO. Okay, let's try to solve this next question. It says in triangle ABC, okay, in triangle ABC, E is the midpoint of median AD. Okay, so we have understood that there is a triangle ABC, bigger triangle ABC. Let's try to draw its sketch. E is the midpoint of median. So then you will draw, after drawing a triangle ABC, you will draw a median from A, which will intersect side BC at point D. Okay, correct. Then AD will be the median, and on that median AD, E is the point which is the midpoint of AD, right? Correct. So that is then area of triangle BED is K by 4 times the area of triangle ABC. So, and you have to find K. So you would say this is the diagram, and we can see that says that area of triangle BED. BED, okay, we have seen BED is the smaller triangle. It's K by 4 times the area of triangle ABC, the bigger triangle. So we would use the property of median, right? So we would say we have to find K, right? That AD is the median for ABC. Similarly, this small BE is the median for AD, right? Triangle ABD, the smaller triangle. So we can say that We know that the property of median is median divides the triangle into smaller triangles of equal area, right? Which means when median AD is being drawn, you would say triangle ABD, area of triangle ABD would be equal to area of triangle ACD, right? ABD will be same as ACD because AD is the median. So you would say, you can give the reason here as, since AD is the median, right? Similarly, you can also say that area of triangle ABC is twice area of triangle ABD. Area of triangle ABC is twice area of triangle ABD, right? So why can we say that? Because they are of equal area, right? So let's name this as equation 1. Similarly, we know area of triangle BED will be equal to ABE. That is, this will be equal to this. The reason for that is BE is the median. BE is the median, right? So therefore, area of triangle ABD is twice triangle BED. Now you in say substituting equation 2, that is area of triangle ABD equal to this in equation 1. So you get 2 into 2, which is 4. So therefore, when you compare this with the given condition was area of triangle BED is K upon 4 times area of triangle ABC, right? So we said if we just simply compare it, we would be able to interpret that K is equal to 1, right? So this is how it works, and it's very simple. Although the question might look a little tricky to us, but we realize that it was very simple, right? So I hope you all understood this area of parallelogram and triangles first class. In the next class, we would be seeing a couple of more theorems. And till then, take care, stay safe during this pandemic, and take care. Thank you.